me enkel af wat hij daar doet. Oké.
So, hello, good morning, everybody. My name is Esther Robles. Just a short comment about all the announcements in the screen. So, the demonstrations, about the food, there are 2 places to take the food, about your mobile phones, so please switch off or put in silent mode. And about the gala dinner, you know, it's this night at 7:30, and as it is planned to be outside, so please your jacket or something like that. So we can start this session that is about network monitoring performance in order to check, in the first presentation, to check SLAs, in order to establish GMPLS, MPLS paths, and in order to check IPv6, IPv4 support in the internet. So let's start with the first one. I invite Vasiliki Pouli from, just a moment, from the NTUA, so this is the University of Athens. She is a PhD student at the Computer Science Division of the Electrical and Computer Engineer Department of this university. So please, go ahead.
Thank you. Hi, everyone. I'm Vasiliki Pouli, as Esther said before. I'm from NTUA, and I'm here to present to you an interdomain SLA enforcement framework targeted for real cause-enabled networks. Yes, I had uploaded another. This is the last. No. Next. Well, the work is done by the development of the work is done mainly by a colleague of mine who wasn't able to come, so I came on his behalf in order to present it. At first, I'll make an introduction, then I'll talk about SLAs in multi-domain networks, and then I will introduce the SLA enforcement framework, and I'll talk to you about the status of our current and future work. Generally, in today's internet, we have services distributed across multi-domain environments. For example, in Europe, we have the GEANT network, which is the 7th generation of the pan-European network infrastructure, connecting more than 30 European countries, pan-European countries, and more than 34, I think, research and education networks, NRNs. It serves more than 3,000 research units and 30 million users. So it enables, with gigabit links, data transfers across resource centers distributed in the European domains. So whenever we need a specific level of quosh across data transfers between the various domains, we need to define specific end-to-end service level agreements in order to maintain, monitor, troubleshoot these service requests across the multi-domain environments. Due to the fact that the end-to-end SLA, due to the fact that the service reservation and provisioning is the responsibility of each administrative domain, the end-to-end SLA across the end-to-end paths is based and produced by the per-domain SLAs according to some merging rules that will be described in later. So generally, an SLA is an agreement, is a template which comprises of some parameters. We can divide an SLA into two objects. The first object is the administrative level object, ALO in other words. It contains the administrative parameters such as contact details, duration and availability of the service, some response times, meaning that is the time needed for a domain to respond to a service request, and also some fault handling procedures. That's the set of actions taken to troubleshoot in case of a problem. And the second object is the service level object, the SLO, which is an object comprising of technical parameters, such as the scope of the service instance, which is details about the interfaces of the ingress and egress interface of the routers, the description of the flow, which is the source and destination IP, along with DHCP values of the IP packets. It can also contain performance guarantees about the network, which are jitter, delay, bandwidth, packet loss. It also contains some monitoring infrastructure deployed in its domain in order to monitor the performance guarantees. And it can also contain some reliability guarantees, such as the maximum downtime and the time to repair. The time to repair is the time needed for a domain to repair a problem. And the maximum downtime is the maximum time accepted by a user for all the problems needed to be repaired in a specific time period. So, as I said before, the end-to-end SLA is produced and based on the per-domain SLAs. So, we have to provide and apply some specific merging rules. Generally, for most of the metrics, the end-to-end metrics, most of them are provided by the union of the per-domain metric values. But for the end-to-end performance metrics, we apply the following rules, as you can see in the slide. For example, for the end-to-end capacity, we take the minimum per-domain capacity. The same goes for the MTU, the end-to-end MTU. For the one-way delay, we take the sum of the per-domain one-way delays. The same goes for the packet loss, the end-to-end packet loss. And for the jitter, we take the RMS value and use its square as an additive parameter. So what we do in this work is develop an SLA framework in order to enable the automated SLA management, creation, publication, and configuration of an SLA in an inter-domain environment. This SLA framework is adopted by the AMPS provisioning system of the GEANT2 project. The AMPS is the Advanced Multi-Domain Provisioning System, which is responsible for the path reservation across the end-to-end paths in Europe, and it's responsible from the reservation from the user request till the configuration of the routers in each domain. So, the architecture of the SLA framework. The SLA framework should be installed in its domain across the end-to-end path because it's responsible for the inter-domain environment, and thus, for the communication of the inter- and intra-domain environment, we have described and defined some APIs. For the inter-domain communication is the communication between the involved and adjacent domains. And there are also some APIs for the intra-communication, which is the communication between the administrator of each domain with the intra-domain entities in the specific domain. The SLA framework should be deployed along with network reservation systems in order to provide something. And that's the end. Esther, it's back. Esther, it's back. Yeah. Should be deployed in network reservation systems in order to provide the end-to-end SLAs for the specific network reservation across the end-to-end path. So, in more detail, as we can see in the figure, you can see in the picture two SLA frameworks deployed into adjacent domains. Each SLA framework can be categorized in 3 levels. The first level is the administrative interface. It's the first box, as you can see. It's a web interface through which the administrator of the specific domain can log in and modify or generally manage, configure the SLA framework, add, remove parameters. In the second level, we have the SLA communicator. It's the next box on the right. The SLA communicator is responsible generally for the intra-domain communication, which is the communication between the different entities inside the specific domain, inside the specific SLA framework. And also, at the third level, we have the SLA manager, which is responsible for the inter-domain communication, the communication between the SLA frameworks of the various domains, of the adjacent domains. The SLA manager is the box which communicates with the SLA manager of the next SLA framework, as you can see. Thank you. So, what is the life cycle of the SLA service provided by the SLA frameworks? The life cycle can be divided in 3 phases. The first phase, it's the creation phase, in which SLAs are created upon a user request. The second phase is the publication phase, in which the SLAs are published. And the third phase is the delivery phase, in which the end-to-end SLA is provided to the end user. Each phase will be described in detail in the next slides. So, in the first phase, we have user requests initiated by the end users and received through the SLA communicator by the first domain in the end-to-end path. And as we said before, the SLA communicator is responsible for the intra-domain communication. So the SLA communicator forwards the request to the intra-domain modules of the SLA framework in order to produce the local SLA. And then the request is forwarded to the next SLA frameworks of the next domains through the SLA manager, which is responsible for the inter-domain communication, as we said before. And when each of the individual domains in the path receives the service request, it evaluates the service request and produces the local SLA, which means that it fills in the corresponding service level objects and administrative level objects of the SLA and stores it to its local database. As you can see, the local database is at the end of the picture. So, after the creation phase, after every SLA in each domain has been created, we have the second phase following, where each domain responds backwards to the first domain in the path through the SLA manager, through the inter-domain module, the SLA manager, and sends its own SLA produced in the previous phase. At the third phase and the last one, the delivery phase, we have the first domain in the path that collects all the SLAs of all the SLA frameworks on the chain and produces the end-to-end SLA provided and merged from the per-domain SLAs according to the merging rules, as I said before. Then the end-to-end SLA is stored in a database along with the per-domain SLAs and other generally internal data or specific data of each domain. This data can be viewed and edited generally via the administrative interface from the manager of the domain. And in case an SLA framework or a specific domain doesn't deliver its own SLA, then the first SLA framework should inform the client that the SLA, the end-to-end SLA cannot be delivered, so he has to make a new request with different level of course in order to make a specific reservation. So, what is the current status of this work? Currently, we're in the phase of integration and deployment of this SLA framework in the AMPS provisioning system. The AMPS, as I said before, is the Advanced Multi-Domain Provisioning System of the Jean 2 project. This means that we are in the phase of communicating the SLA module with the other AMPS modules, and in the phase of debugging, and I think till October we have to finish it. And this SLA service is supposed to be triggered by the end user upon the service request, and it will provide the end-to-end SLA for the specific user network reservation. So the SLA generation process in the AMP system, in a few words, it will be more or less the same as I said before. It will follow the 3 phases of the SLA service life cycle. In the first step, the administrative interface will receive the user request for an SLA service, following a specific AMPS reservation for an end-to-end path. Then the SLA communicator, which is responsible for the intra-domain communication, will forward this SLA service request to its own domain in order to produce the local SLA. And the SLA manager, which is responsible for the inter-domain communication, will forward the request to the rest domains in the path in order for them to produce their own per-domain SLAs. So, in the third step, each domain will generate its local SLA and send it to the SLA manager, through the SLA manager, to the previous AMPs of the domains. And the first SLA manager of the first domain, that is, will collect all these per-domain SLAs and produce the end-to-end SLA and store it to the local database and deliver the end-to-end SLA to the end user. As a future work, we are intending to deploy these SLA frameworks into AMP systems in various areas across Europe, and also in order to make network path reservations and offer SLAs for these reservations. And we also intend to install various monitoring tools in order to take measurements and evaluate the SLA framework and monitor the SLA guarantees, and also troubleshoot in case specific SLA violations take place. So, that is more or less the presentation. For more development details, you can contact Simarinos.
Is there any question for Vasilikis? Yes. Okay.
My name is Paolo Barbato from National Research Council in Italy. I have a question for you. It's really complex to maintain such an environment, such a framework to manage quality of service. What's your reaction on the news that Janet in UK has abandoned the quality of service as a way to manage such high-quality connections, since they prefer to overdimension or overprovision the link because they say it's too complex to maintain, so we prefer give bandwidth. So what's your reaction on this?
If the user requests an if the user requests an SLA for this network reservation, you can deploy an SLA framework like that and produce the SLA for his reservation. It depends on the user if he requests an SLA or not.
Yes, but it's a lot of complexity to put in touch NRANs on this subject. For example,
that's why
to react to a fault. Just think about that. We construct a perfect link, but we have a fault, and just we have to react in short time, the shortest time.
Yes, that's why the framework should be automated, so the requests should be automated and forwarded to the next domains in quick time. So the response to the end user is very quick. And about the fault handling procedures, whenever something goes wrong, it's in development stage. We are trying now to integrate with the AMPS provisioning system, and when we finish that, we are intending to provide handling procedures in case something goes wrong.
So my last question is, in add to Greek and RAN, what other NRAN are working on this subject?
Currently, only those that provide the AMPS system.
So do you know who?
GRNet, Dante, and Poznan.
Yeah.
Okay, thank you.
Merci.
Yeah, just to say a few words about your question, for me this is another service. Yeah. So an NRAN, maybe Janet prefers to over-provision its network, but other networks try to provide services to the universities, to the users, and this is another service. It's a way to provide to the user some kind of trust or of security that the service will be delivered.
It should be that, yeah.
Are there any other questions for Vasiliki? No? Then thank you very much for the presentation. Our next speaker is Shuichi Okamoto. He is an associate research engineer of the KDDI Research and Development Laboratories, and he works on GMPLS technology from the operational point of view. So please.
Thank you, Chair, and hello, everyone. My name is Shuichi Okamoto from KDDI R&D Laboratories, Japan. What I'm going to talk about today is the prototype of MPS, GMPS path-based booking system for user-oriented BOD, bandwidth on demand system. Here is the agenda of my presentation. Firstly, I briefly talk about the background and then introduce the architecture of BOD services using the GMPS path-based booking system. And then I'll show the functionalities and specifications of developed booking system. Then I'll explain the algorithm on path calculation and some experimental results and booking systems window. Then I'd like to talk about the feature consideration, and then I'll conclude my presentation. Well, the BOD service is very attractive aspects for both network operator and service users, and MPLS, multi-protocol level switching, and GMPLS, generalized MPLS network is suited for the BOD service because of the quick provisioning of path-based high-quality connectivity for various types of QoS quality of services, considering the bandwidth and priority and so on. So the MPLS or GMPLS-based BOD service can meet the demand for high bandwidth and high-quality connectivity for such as grid technology, high-definition TV transport, and so on. However, current network implementation is that no time information is managed and considered. So, to realize the reservation-based services, we have to realize time information management into the network. Mainly, I think there are two ways to implement time information management into the network, current network. The first way is to extend the existing protocols and implement into existing network. But this way is very hard and tough work. So I'd like to use the second way. The second way is to develop the centralized booking system and then introduce it into the current network services. Then I'll introduce our proposing architecture of BOD services using MPLS, GMPLS, path-based booking system. Here is the overall architecture of BOD services. The booking system has mainly 5 features. The first feature is to retrieve the network resource information from the network management system and then create the network resource database by adding the time information. And the second feature is to receive the path reservation request with the QoS parameters from the users. The third feature is the path calculation for each reservation request. And then the booking system returns the result to the user. The fourth feature is to provision the MPLS, GMPLS path with the QoS parameters by generating the path request message toward the NMS. The last fifth feature is the management and the optimization functionality for the network or service operators. This is a little bit more detailed architecture of developed booking system. The booking system has 5 sections, as I told, and in the user interface section, we utilize the HTTP protocol to communicate with user or operator. So the service user and the operator can access to the booking system by using the web-based GUI. On the other hand, the interaction between a booking system and MPLS, GMPLS, NMS, we utilize a CLI-based API for provisioning the passes, and for the network resource database retrieving, we utilize the XML-based files to the API. This is why this is simply because we utilize the existing MPLS, GMPLS, NMS to develop our booking system. Well, I'd like to explain the functionalities and the specifications of our booking system. The booking system has mainly 5 features, as I told, and in the real network management mode, the booking system collaborates to the NMS and receive the path request from the users. and then provisioning the MPLS, GMPLS LSPs by collaborating the NMS. On the other hand, we have the booking system has the additional feature about the simulation mode. In this mode, the booking system requires no real network or NMS, and no LSP is provisioned. This is the helper tool to the planning the GMPLS or MPLS network. This is the specifications for the user. Some information should be input toward the booking system for the reservation, such as the source and destination location, and the start date and time, service duration, bandwidth, types of network, just MPLS or GMPLS network, and the QoS parameters. In the QoS parameters, for the MPLS network, we utilize the 4 class of services based on diffserv aware TE. And in the GMPLS network, we set up 8 priorities based on the preemption. In addition, the user has to input the types of residency. This booking system provides 4 types of residency. I'd like to present this later. As the user management, very simple implementation. As the administrative function, the booking system controls the administrative condition about the available ingress or egress nodes for each user. In order not to mistake of the reservation in the unavailable nodes, and for the user authentication method, we utilize simple combination of username and passwords. Of course, we can use additional security management method. This prototype, to simplify the implementation, we utilize the simple authentication method. In addition, we express the to be discussed issues about the fairness control of booking, notification of the unavailability of reserved paths because of sudden network failure and so on. I'd like to express these issues later. Well, here I'd like to introduce the path calculation algorithm for my booking system. The booking system calculates the path for each reservation request by solving the minimum cost flow problem, considering the necessary conditions of residency types, starting and ending time, bandwidth, QoS parameters, and so on from the user's request. And here we have to consider the booking system as because that had the time information. From this slide, I'd like to talk about the path calculation algorithm considering the QoS. Firstly, the booking system checking each T traffic engineering link whether it meets the necessary condition for the requested path. Well, booking system has mainly three-dimensional database consisting of available bandwidth, QoS parameters, and the time. At the first step, the booking system extract the two-dimensional database consisting of time and available bandwidth from the three-dimensional database. By focusing on specified QoS values that is requested from the user. Then the booking system check the two-dimensional database consisting of time and the available bandwidth. The blue line showed the available bandwidth at the time slot. Then the booking system checks the available bandwidth in a whole requested time span. If the T-link has enough bandwidth through the requested time span, the T-link is available. So the booking system adds the temporary topology database into topology database. And if the network type is the GMPLS, the booking system also checks the constraint such as GMPLS specific issues such as switching capability and encoding type and so on. And then in this way, the booking system checks all T-links and construct the temporary topology database consisting of available T-links. And then the booking system calculates the path based on available topology, considering the resiliency types and minimizing the user's requested issues, such as cost or number of hops and so on. Here is the types of resiliency. In the booking system and the path calculation, the types of resiliency is very important to the path calculation. There are 4 types of resiliency. First is the redundant edge router, 1+1, and disjointed route. Second is the redundancy router, disjointed route, as you can see the right figure. And then the third type is, you can see in the left figure, non-redundancy router, and 1+1 path with disjointed route. And the last type is the no redundant type. The booking system calculates the constellation, calculates the path considering the path types and the disjointed configuration. Then I'll show the experimental results about the booking system. This is the reservation window for our booking system. This is the reservation window for the user, and the user, after the authentication, user can create the reservation, modify the reservation, cancel the reservation, and check the reservation. This is the reservation, adding reservation window. As you can see here, the user has to specify the network types, beginning data and time, and service duration, source and the destination node, and the quality of services. And the bandwidth and the types of residencies. Well, this is the path calculation results for the user's request. This pop-up window shows the calculated route information representing the hop list of each LSP. In this path calculation, the booking system can calculate, figure out all requested paths, but if no available resource to set up all to fill all types of LSP, the booking system returns the reservation error to the user. This is the operator's management window. Now the operator is focusing on red line in right figure T-link, and the left view graph shows the available bandwidth against the time slot. The different colors indicate the different users' reservations. So the network operator can easily monitor which link, how much bandwidth, and which T-link is utilized or not utilized in the GUI window. Well, I'd like to explain the re-optimization of reserved paths. Re-optimization of booked paths means the once calculated results, check the once calculated results, and then recalculate the requested paths in some orders. For the optimization of network resources, or in the case of network failure or planned network maintenance and so on. However, the network resource availability depends on the recalculation, re-optimization order of booked paths. In other words, the booking system calculates the path at the time when the user requests the path. And the booking system calculates in the requested time, at the time requested time, and after the many reservations. To be honest, the booked path is not optimized. And if we can check and re-optimize the reserved paths, the availability and the utilization may be improved. So we evaluated these functionalities. And however, the re-optimization, as I told, the re-optimization should be done one by one. Because the network resource database information depends on the reservation and the reserved results. So the optimization should be done based on such as hop counts, service duration, bandwidth, starting time, and the combination of these parameters. And the optimization results may be measured by the distribution of congestion rate for each link. This is the re-optimization window for the network operator. The network operator has to input the target reservations for re-optimization by specifying the range of the starting date and the time, and then the network operator has to select the recalculation order of reservations. We have to have to modify the recalculation order and the measurement index about the recalculation results. Well, I'd like to talk about the future consideration about the booking system. As I told before, the booking system has to consider the fairness control of booking. In other words, a user reserved many passes, so that other user cannot use the reservation, cannot use the services or specified passes. So how to guarantee the fairness of network usages for each user? In the research and educational network, such as the testbed, we have to consider the measurement method or index about the fairness of network usages. Otherwise, the network or service operator might be a coordinator or the god. In contrast, in the commercial use, it's very easy to solve this problem by interworking with an accounting system in order to charge a commission to each request and reservation. In this sense, we may refer to the booking and buying system of the air tickets. In the booking and buying system of the air ticket has some rules that any reservations will be expired if the user does not pay within 48 hours, or the early discount rate for discount rate for early reservations, and some cancellation policy, and so on. Other problem is the notifications of the unavailability of reserved passes caused by a sudden network failure. The booking system can re-optimize and recalculate functionality for the network failure, but if the booking system cannot help all requested passes, the user, the booking system has to inform that condition to all users. This is the future issues, and now we are investigating the method and so on. Well, I'd like to conclude my presentation by saying things described here. Our proposed architecture of BOD services using MPLS, GMPLS path-based booking system is explained, and specification, functionalities, and experimental results using our developed booking system by focusing on the path calculation algorithm and the path recalculation, re-optimization functionality of result path. And also, I explained the future consideration about the fairness control of booking and how to inform the availability of reserved passes, and the modifier and further consideration is required about the time domain extended network resource database and reservation status, and so on. And that's all of my presentation. Thank you for your kind attention.
Well, are there any questions to Shuichi? Yeah.
Sorry.
Hello, Stefan from Nordinet. If I understand you correct, this booking system is something you've already created? Okay.
Yes, we developed the first prototype.
Okay. When you talk about this booking system being integrated with a network management system, which network management systems have you tried, tested this booking system against?
For my research issues, the NPS and the GNPS management system is already exists before my research of this booking system. And to simplify the provisioning and network resource database retrieving, I decided to use the existing existing NMS.
Okay, which is it, a specific vendor network management system or something that is already developed?
No, I don't think that this booking system is only applied to the specific NMS or specific vendors, because the provisioning and the network database description is retrieved from the NMS. So we can change the network resource database construction or retrieving method or provisioning method. The provisioning and creating database functionality can be easily changed.
Okay, because I find that a lot of network management systems, they use proprietary ways of communicating with them. And I was wondering, something that would be interesting to know is, how have you managed to integrate your booking system with all these different vendor-specific ways of communicating, firstly externally to other systems, but also to their own equipment, to actually get the network management system to perform these actions that you want to have done with your booking system? To, for example, say that someone wants to initiate a path somewhere or a connection for a specific bandwidth. How is your booking system able to get proprietary systems to actually implement this in their equipment?
Your question is the proprietary system devices?
Yes, basically, which vendor equipments have you tried integrating to get this to work?
The network devices control and management themselves should be done by the NMS. So if the network operator or service operator want to change, modify or upgrade the network service or network devices or network management system, it's very easy to adapt to the booking system.
Okay, because what I've seen, it's not that trivial to actually get the network management system.
I think that you can maybe continue, because there are some other questions.
Sorry.
So you can
Thank you.
Continue. Okay. There are more questions. Well, one there and another here. After that. Yes. Okay. Okay.
Okay, Evangelos Kanyotakis from ESNet. I'd like to ask you if you've considered multi-domain capabilities. Right now, this seems to be booking things in a single domain.
Currently, we are considering only in the single domain, but in the multi-layer collaboration and communication, we have to consider the interface between the booking system or other management system. So, and how to guarantee the MPLS LSP by using through the multiple domain. There is some problems about NMS and the booking system. But now we are considering the interface between these types of booking systems for the multi-domain connectivity. In the phosphorus or other project, the service integrates service and integrate service on the multi-domain issues, and we also are considering now the multi-domain or multi-layer integration.
Okay, thank you.
Any other question? Yeah.
A short question. Does the end user directly interact with your booking system, or there is a sort of help desk that is a front end to the end user?
Once more, please. I'm sorry.
So does the end user directly interact with the booking system, or there is a sort of front end help desk that is in the middle?
Currently, we are thinking about the direct connection to the booking system from the end user. In the meaning of the security issues, we have to set up some VPN or other secure method to communicate with the user GUI to the booking system.
Thank you.
Okay. Any other question? No? Okay. Then thank you.
Thank you very much.
And I invite our next speaker, Carlos Friacas, to present their work. Carlos Friacas works for the Portuguese National Research and Education Network, and his job is mainly managing the backbone. So, please.
Yes. Well, firstly, thank you for coming to this session. My talk is about some probes we have deployed on our NRN network, and which we are trying to extend to also use IPv6. So this is a short agenda. From that deployment inside our network, we also understood that there are other similar systems that we also analyzed to see if we could get any significant results. So we also went to analyze the IP performance metrics system, which also has one node inside our network, and the RIPE TTM system, which is deployed not only across NRN networks but also inside some commercial networks. So about IPv6, at this point we know scientists need networks, but they don't really care about which protocol they use to run their applications. So we also know the IPv4 available spaces near its end. That doesn't mean IPv4 will stop working. No, it won't. For us, we still have a lot of IPv4 space to distribute to our NRN members. But that's mostly irrelevant because we have a policy of also deploying IPv6. So on this framework, our board issued a challenge to our members in order for them to deploy some basic services like web, DNS, and email over IPv6. So we have a small website in place where every member can log in and tell us how many servers they have and how many servers they already have working with IPv6. So, but back again to the monitoring infrastructure, we deployed QoS metrics solution, which is Linux-based and uses KTP, which is a proprietary time protocol. Unfortunately, from the time this presentation was made, we had about 26 probes deployed around our network, but only 14 of those probes were operating in IPv4 and IPv6. So the main problem here is just that I'll talk about it in the next slide. It's the place where these probes are deployed, because we state that we provide IPv6 in all of our backbone, but we don't guarantee that IPv6 exists inside our members' networks. So this probing infrastructure gives out data about packet loss, delay, and jitter. So this is the key problem for deploying IPv6 on every of our probes. If the probe is deployed on our backbone, it will work under the true protocols. In some cases, the probe is inside the member network, and if that university or school already has IPv6, so it's working also in v4 and v6. But we are still a bit far from getting all the data right from this system, because we still find some problems with our readings. But from what we've seen from comparing v4 and v6, from the small set of data we did manage to get. So we've seen pretty much all cases. We've seen better values with the IPv6 data, and slightly better in other cases. But in the majority, the data was slightly better, but on the v4 side. So for the other system, the IP performance metrics, we have some nodes of this system in our network. We have probes deployed in Oporto, Coimbra, and Aveiro, but unfortunately, well, as the University of Aveiro does not have IPv6, this probe is not really working with IPv6. When I was looking at this domain, I also found an extra problem. Well, I've previously seen all the probes spread around Europe. When I clicked for the data about IPv6, I discovered that most of the probes were not really doing measurements over IPv6. So in April, only 6 probes were running over IPv6, and after some emails, some probes were added to this v6 measurements network, also in v6. So you can see here a small graph. If you go to the page of this project, at this moment you will see a bit of more nodes, because this evolved from the end of April in the last month, so that they added IPv6 capabilities to some more of the deployed nodes. The right TTM is probably the most advanced of these systems with global deployment, which is done since several years ago. We have 2 of these global deployment architecture, 2 nodes in our network. Sometimes from experience, we even get emails from the RIPE team saying, well, there is something not working with IPv6 on one of the boxes. Can you please check? So this was some early work we did regarding IPv6 in Portugal. It was the deployment of these boxes. So I was aware of the system for quite a while. And well, for doing some comparisons, we chose from the larger set of probes. We chose 30 probes and could get that from this set, 16 were inside NRNs and 14 not inside NRNs, so deployed on commercial networks. And here we find some interesting differences. Perhaps the best conclusion is that if we divide the one-way delay on IPv6 over the one-way delay over IPv4, if we do an average on the academic nodes, the result is near 1. So it means the quality or the latency inside the academic domain, inside the NRNs connected to GN2 are almost at near quality. Unfortunately, this is not happening with the set of probes deployed in the commercial domain. So we tested it from Lisbon to the IPv6 and IPv4 one-way delay values, and the difference is quite visible. Reasons for this to happen? Well, IPv6 is probably at a more advanced stage on research networks, and there are some bad setups with tunnels and also problems with peerings. Some more data about packet loss, which is some measurements which are also important. Here we also see almost no difference between the IPv6 and the IPv6 and the IPv4 values, but on red, on the commercial values, we see a significant difference. So my question is the IPv6 network being monitored using the same quality standards? Well, at this time, I would say probably no. So this is the general idea of this work, the 3 domains, which all involves our network, RCTS, the Portuguese Research and Education Network. We did have some problems, mostly with our own system and with getting the data from the GN2 deployed probes. And the overall conclusion is that we need really to do more work on this. So the quality comparison between the IPv6 and the IPv4 infrastructure, which is in the most cases supported by the same devices, is, in my opinion, unavoidable. So people will notice if they get a poorer performance for their applications over v6, and if they find they were using v6, they will ask the questions. So along with this, we can also say that IPv6 status is evolving, but evolving very slowly. I usually call IPv6 as the low priority protocol because people are deploying VoIP, people are deploying wireless campuses, people are doing almost anything, but IPv6 is the low of their priorities. Unfortunately, for for people which understand that we really need this in place and that aim for a smoother transition into IPv6. So more work. We need to deploy more probes and go for have 100% coverage on the probes deployed at our network. From the data I've showed in this work, it's only related to the Lisbon node always, because we have a GPS synchronization problem in our second main node in Oporto, so we also have to fix this in the near future to have a richer set of data. And we need to keep pushing the guys that are deploying v4 only probes to get more IPv6 on the stuff they are doing. So this is the acknowledgements page, and any questions?
Any questions for Carlos? No? I have one question. When you show the results in the tests that have been done within your network, in the national network, you show that a better performance for IPv6 compared with IPv4. Have you any idea of why? You show several trunks saying from this city to this city, from this city to this city.
Probably I didn't state this clearly. All the measurements were done from the central node in Lisbon, and we are not measuring end to end, but only Lisbon to end.
In the trunk. But the results were worse than with IPv4. So my question is if you have an idea of the result.
No, the results, the measurements are not even done from Oporto to the other probes. The probes are not fully meshed. So we are not measuring from Coimbra to Faro. We are just measuring Lisbon to Faro and Lisbon from every other node. So.
But the IPv6 results were worse than the IPv4 results. Slightly worse.
They are slightly worse, but there are no significant differences and no explanation where we have the case where IPv6 data is slightly better.
Okay. And the second question is that you say that it's necessary more development of IPv6 because it's not well deployed as your results above all with the commercial network is show. Have you any idea of what can be done to improve the IPv6 deployment within the commercial environment?
The problem here is the connection between our research and education networks and the commercial networks. We have cases where nodes from this measurement system are placed in Europe, and we get strange paths going to other continents. That's a catastrophe for IPv6. So we need really to get closer with more peerings and more getting the networks together.
Okay. Any other question? Okay, then thank you very much. So it's a bit soon, but lunch is waiting for us. I remember you that there are 2 places for taking the lunch. One is in the second floor, as you know, the normal area, and there is another room where food is going to be served. Is the Vives room, okay, in this floor. So enjoy your lunch, and we'll continue this afternoon.